MAT1033 Final Exam Review Question 20. We are to solve the equation, and we've got the quantity 3x minus 2 squared, and that equals 4. Okay, it looks as if, and I'm not going to do this, but if I were to FOIL this, because it's 3x minus 2 times 3x minus 2, I would get a quadratic. It is set up already in a form that we could use the square root method. So I'm going to take the square root of both sides. And in doing so, remember that when we do that, when we take the square root of both sides, we end up with two answers. So we've got to show that this could either be the positive square root of 4 or the negative square root of 4. Okay, now I know that there's a simpler form for that, but I'm going to isolate x first, and then we'll worry about writing this in the simplest form. Now, to get x alone, the first step over here on the left is I'm going to add 2 to both sides, and I'm going to put it in front of the plus minus because there's two different values there. So here I end up with 3x is equal to 2 plus or minus square root of 4. Yes, I know 4 is a perfect square. I can take the square root of it, but I'm not going to do it yet. I am going to perform the next step to isolate x, which is dividing both sides by 3. Now it's both sides. Okay, so make sure you draw that fraction line long enough to capture 2 plus or minus square root of 4 all over 3. Alright, now we have two solutions. They're just not in simplest form. So let's write them out. 2 minus the square root of 4 over 3. And 2 plus the square root of 4 over 3. Then we will decide if there's a simpler form. Well, now, yes, square root of 4 is 2. So this value here would actually be 2 minus 2, or 0. 0 over 3 is 0. So there's one of our solutions in simplest form. And then the other one, we have 2 plus 2, which is 4, which indicates our other solution is 4/3. So the two solutions should be 0 and 4/3 in simplest form, and of course we would plug those in to check them. MAT1033 Final Exam Review Question 21. Solve the equation 4x squared plus 1 equals 0. Now, we could certainly try several methods, but it appears to me that it would be very easy to isolate the x squared. So I'm going to use the square root method. And in order to do that, I've got to subtract 1 from both sides, okay, to isolate the x squared. So I'm going to end up with 4x squared equals negative 1. And then divide both sides by 4, and have x squared is negative 1/4. Now students have a tendency here, when you take the square root of both sides, which is what we need to do, is to just drop the negative because you don't like the idea of there being a negative under a square root. And truly, this is going to end up with some values where we're trying to take the square root of a negative. And based on what we've already covered in Chapter 9, we realize that, oh yeah, there are some imaginary numbers, complex numbers, that we have an I form for. So we're going to have to look at that from that perspective. Okay, so we've got x. Well, better yet, let me go ahead and show the two solutions. Then we'll put them in simplest form. Or in this case, simplest form with their I form. So we've got negative square root of negative 1/4, and then we've got the positive square root of negative 1/4. Okay, now let's clean it up a little bit. We do have a quotient rule for radicals that allows us to split the fraction radicand and give the top its own symbol and give the bottom its own symbol. And what I'm doing here is I'm taking this expression, this value, and I'm going to put it in a different form. Okay, so square root of negative 1 is I, so this would be negative I, and then square root of 4 is 2, so that's negative I over 2. So one of our values in its simplest I form would be negative 1/2 I, because remember there's a 1 here. 1 times a value is itself, which is the multiplicative identity. Okay, so let's work on the other one, and you'll notice that it looks a lot like the first one we did. So we're going to give the top its own symbol, square root of negative 1, and then square root of 4. And again, there's the I, and then that's square root of 4 is 2. So we have I over 2, which is actually 1/2 I, if we consider that this is 1 times I, and those are our two solutions, imaginary solutions.